Hi everyone, welcome to day 4 of limits. Today's learning target is I can evaluate a limit 3 different ways. Please take a look at the do now questions and pause the video to answer them. For number 1, find the limit as x approaches -1 of x times x minus 1 squared. I use substitution and substituted -1 in for x and got the final answer to be -4. Number 2, the limit as x approaches -2 of x squared minus 4 over x plus 2. I can't use substitution because it would make the expression undefined, so instead I factored the numerator and the denominator. X plus 2 cancels out in both the numerator and the denominator. I'm left with x minus 2. Then I use substitution. -2 minus 2 is -4. In this lesson, we are going to discuss how to evaluate a limit the 3 different ways, 2 we are familiar with already. Let's first define what evaluate means. Evaluate means to calculate the numerical value, which we've been doing in the do now questions. Now, the 3 ways to evaluate a limit, the first being substitution, which we practice in the do now, factoring, which we practice in number 2 in the do now, and the conjugate method. Let's take a look at the 3 examples of each method. So number 1, substitution. What's the limit as x approaches 0 of x squared minus 1 over 2x plus 3? Using substitution, I'm going to substitute 0 in for x. And I'm going to get -1/3. I can always check this with a table or a graph. Next, let's look at factoring. The limit as x approaches 2 of x squared minus 6x plus 8 over x minus 2. Let's factor the numerator. What multiplies to 8 and adds to -6? That's -4 and -2 over x minus 2. Again, we see cancel out the numerator and the denominator, and I'm left with x minus 4. And remember, I can substitute the 2 in now, so 2 minus 4 is equal to -2. Next, we have the conjugate method. If we have the expression radical x minus 4, what's the conjugate? Take radical x, instead of a -4, we're going to have +4. I'm going to take that idea and apply it to this expression. What's the limit as x approaches 16 of radical x minus 4 over x minus 16? So I'm going to multiply the numerator and the denominator by the conjugate. Radical x plus 4, radical x plus 4. Radical x times radical x is x. Radical x times 4 is plus 4 radical x. -4 times radical x is -4 radical x. -4 times +4 is -16. And for the denominator, I'm not going to actually multiply it out. I'm going to leave it, and you'll see why in just a moment. So let's simplify the numerator. So this goes away, this goes away. I'm left with x minus 16 over x minus 16 times radical x plus 4. Again, more canceling. I'm left with 1 over radical x plus 4. Now, this turns into a substitution question. So notice as x is approaching 16, so 1 over radical 16 plus 4. This is going to be 1 over 4 plus 4, which is 8. 1 over 8 is going to be my answer. If you turn the page, it says evaluate the following limits using the substitution or factoring method. So take a few moments right now and solve these 4 problems. Please pause the video. In problem number 1, the limit as x approaches 2 of x squared plus 5x, we substitute 2 in for x, and the answer is 14. Next, for number 2, again, we substitute -1 in for x. The answer is -14. Number 3, we have a factoring question. Factor the numerator and the denominator. The x plus 3's cancel out. I'm left with the limit as x approaches -3 of x minus 4 over x. Substitute -3 and you get 7/3. Finally, let's look at number 4, the limit as x approaches -2 of x plus 3 over x squared plus 5x plus 6. So the first thing I did was factor the denominator. I then canceled out the x plus 3's. So I wanted to find the limit as x approaches -2 of 1 over x plus 2. Now notice, if I were to substitute a -2, I would get a 0 in the denominator, which would make it undefined, meaning that the limit does not exist. If I take a look at the graph, so for example, I graphed 1 over x plus 2, and I noticed as x approaches -2 from the left, we're approaching -infinity, and from the right, we're approaching infinity. Because those don't match, therefore the limit does not exist. Next, for numbers 5 and 6, evaluate the following limits using the conjugate method. So again, try 5 and 6 on your own and pause the video. So we have to multiply by its conjugate. So radical x plus 1 over radical x plus 1 plus 1. When I multiply that, I end up getting x plus 1 plus radical x plus 1 minus radical x plus 1 minus 1. There will be some canceling out in the numerators. This goes away. This goes away. The 1's cancel out. So I'm left with x over x times radical x plus 1 plus 1. Now notice the x's then do cancel out. So I'm left with 1 over radical x plus 1 plus 1. Now remember, the limit as it approaches 0, so let's substitute 0 in. 1 over radical 0 plus 1 plus 1. So this really turns into 0 plus 1 is 1, radical 1 is 1, 1 plus 1, so this is 1/2. And to write this properly, we should write the limit as x approaches 0 of radical x plus 1 minus 1 over x is equal to 1/2. This would be the proper notation. If we notice number 6, the limit as x approaches 0 of 1 over x plus 2 minus 1/2 all over x. In order to subtract the expressions in the numerator, because they're fractions, we need common denominators. So I'm going to multiply the first fraction by 2 over 2, and the second fraction by x plus 2 over x plus 2. I'm not going to worry about the denominator right now. So I'm going to be left with 2 over 2 times x plus 2, because that's going to be my common denominator. And then I'm going to be subtracting minus x plus 2. I'm going to put that in parentheses. All over x. So let's combine the numerator. So the 2 minus 2 go away. So I'm left with negative x over 2 times x plus 2 times, keep change flip, 1 over x. Notice the x is going to cancel out, but there still is this negative, so don't forget that. Negative 1 over 2 times x plus 2. If you did want to simplify that, negative 1 over 2x plus 4. And then remember, the limit as x approaches 0, I'm substituting a 0 in. So negative 1 over 2 times 0 plus 4, which would give me negative 1/4. So for this question, don't forget about finding your common denominator. If you flip over to the next page, we have practice problems 1 to 14. Numbers 1 through 10 involve limits. 11 to 14 is a review of f of g of x. So take a moment right now, pause the video, and try these questions. Let's take a look at the answers. So for number 1 and for number 2, we used substitution. Number 3, I graphed it to see where it was approaching. It does not exist. It's approaching infinity. Same for number 4. Number 5 and 6, I factored. Seven and 8, I also factored. And for 9 and 10, I substituted. For the next page, for numbers 11 to 14, evaluate each limit of f of g of x as x approaches 2 for each of f of x and g of x. So I substituted 2 into g of x, and then whatever value I got for g of x, I substitute that in for f of x to find my answer. Take a look at questions 11 to 14. Again, I hope this was helpful. Please message me on Teams through chat if you have any questions. Thanks so much. Have a great day.